The objectives of care and appearance testing are to rate and place values on the performance of fabrics and products with regard to the care and cleaning of the products and the appearance after the care procedure. In this segment, an emphasis will be placed on a better understanding of the units, dimensions, terms, and other aspects of care and appearance testing. It's human nature to rate or judge most aspects of life. Properly done, a rating means a classification according to a standard. A rating system or rating procedure is a process of determining and assigning a score, a grade, or a value to a material or product by comparing it to a standard reference model or scale. By definition, a grade is a step or degree in an established scale. Also, a grade is a symbol, a number or letter used for any step in a standard reference scale for judging a quality characteristic. A reference scale is a range of changes in a material that serves as a standard. The scale may be plastic replicas, colored tiles, gray tiles, colored chips, gray chips, a series of photographs, or any materials that represent a range of visual changes. In testing, a reference scale should represent changes that are likely to occur during testing. These representations or replicas are designed to represent a progressive change, as might occur in product use and care. To properly rate a performance, the following must be provided. First, a trained rater or evaluator. Second, a precisely controlled testing environment as related to lighting, temperature, and humidity. Third, standardized rating scales. And fourth, a reporting system. A rater is an estimator who is thoroughly trained to assess and assign a rating or grade of a material against the standard. He or she should have a good knowledge of textiles and apparel materials and their relationship to the test. Good vision and recognition talents are keys to success. When one or more raters are used, they must work independent of each other so as not to be influenced. In addition, for color fastness and some other evaluations, color blindness should be ascertained, as the ability to properly see color is of paramount importance. Carefully controlled testing conditions are keys to accurate evaluations. Controlled conditions in the testing laboratory relate to room temperature and % relative humidity. Lighting conditions are also vital to accurate assessment. These relate to light source, direction or angle of the light, the intensity, and viewing surfaces. The surrounding surface color, masking papers, forms, and cutouts that are used must also have special considerations. Standardized rating scales are used to compare the tested specimens to an approved series of replicas. In these instances, a sample of the standard, a specimen that has not been tested, and a specimen that has been tested are compared. Finally, the rater assigns a rating number for the difference between the tested and untested fabrics. Standard reference scales are used. The most commonly used rating system is the AATCC Evaluation Procedure 1 Gray Scale for color change. It's used to rate color change in textiles as a result of testing. This procedure paired chips from light gray to dark gray. As a result, this is a 9-step scale with half rating points permissible. This means that there can be ratings of 5, 4 to 5, 4, 3 to 4, 3, 2 to 3, 2, 1 to 2, and 1. Color change is a variance or alteration of the color of a specimen regardless of cause, type, lightness, hue, chroma, or any combination of these. The change can be in the surface characteristic as a result of fuzzing, surface flattening, or other surface distortion. A grayscale refers to the pairs of standard gray chips or tiles that relate to the corresponding numbers of the scale. The difference between pairs of tiles corresponds to its number value. In this procedure, the rating scale ranges from 1 to 5. In this type of system, the scale is linear, with a rating of 1 representing the greatest amount of change and a rating of 5 representing no change between the samples evaluated, or not enough to represent a 4 to 5 rating. For example, a 3 to 4 rating indicates a rating of change between values of 3 and 4. This 3 to 4 rating represents the same incremental change in the tiles as the samples being compared. In addition to the grayscale rating, the change in hue, chroma, and lightness may also be recorded. For example, a rating of 4 greener would indicate a 4 grayscale rating in color change that is also greener in cast. Although an experienced evaluator can see millions of colors, this scale allows for communication of color change without high levels of color discernment or color training, and at a minimum financial investment. Also, expensive color instruments are not needed. This procedure is used for tests such as light fastness, laundering, accelerated laundering, perspiration, and finishing. Here, the rating is done horizontally for ease of demonstration. The actual rating would be done vertically. To execute the rating, a piece of the original non-tested textile and its corresponding exposed test specimen are placed side by side in the same plane and oriented in the same direction. Special care should be used to have straight edges for each specimen, which are placed side by side. The example shown here is a light fastness specimen that has been exposed for 20 and 40 hours. The left side of the specimen was exposed for 40 hours and will be rated. The grayscale is placed along the edge of the specimen with the tiles most closely matching the color change next to the exposure. Notice that the evaluation booth background is the color specified in the test method. Also, the specimen is mounted in a standardized white card so as not to interfere in the rating. The gray mask provided with the scale is placed over the samples and the scale to eliminate any influence of the surrounding areas. The surfaces are illuminated with a daylight simulator of standard values. The light incident upon the surfaces is at a 45-degree angle and the direction of viewing at 90 degrees to the plane of the surfaces. The tiles are moved under the exposure window until the rater has determined the level of color change. The perceived visual difference between the original and tested textiles are compared with the perceived differences represented by the grayscale. The color fastness grade is that number of the grayscale tile pair whose contrast corresponds to that between the original and tested specimens. In this case, a rating of 3.5 was given. A grade of 5 is given only when there is no perceived difference in color or contrast between the original material and the tested specimen. Another procedure is the AATCC Evaluation Procedure 2, Grayscale for Staining. This procedure allows for evaluation of staining of undyed products during color fastness testing. Staining is the unintended transfer or pickup of color to the sample from 1. Exposure to a colored or contaminated liquid medium, or 2. Direct contact to dyed or pigment-colored material when contaminant color comes from mechanical surface action such as rubbing or direct sublimation. This grayscale consists of white and gray chips or tiles with the level of contrast in gradients. It's used primarily to measure staining for laundering, accelerated laundering, and crocking. The test methods that implement this procedure use a test fabric called a multi-fiber test fabric or a multi-fiber test strip. This fabric is made with woven filling band strips. These weft strips are banded by different fiber contents. These fibers are standardized by type of fiber and their order in the strip. This means that the potential staining color is fiber type specific. Stated another way, the colorant has a bonding preference due to chemical composition of the fiber type. Typically, the dye or colorant will not stain all fibers, or those applicable even at the same depth of shade. Some of the multi-fiber bands will stain, while others may not. Whichever stained band of the test strip shows the most contrast will be the one that is rated and assigned a grade. There are 2 multi-fiber strips commonly used. One strip has bands in the following order: acetate, cotton, nylon, silk, viscose rayon, and wool. The other multi-fiber strip contains acetate, cotton, nylon, polyester, acrylic, and wool. The choice of multi-fiber strip depends on the fiber content of the sample being tested and its end use. Regardless, the multi-fiber strips are always rated in their order in the strip. To execute the rating, the specimen that has been tested for staining is viewed upon a 45-degree mounting board. The incident of light upon the surfaces is at an angle of approximately 45 degrees, and the direction of viewing approximately perpendicular to the plane of the surfaces. The mounting surface is colored to the standard color to prevent influence of unwanted color. If the fabric is not opaque, then it's backed with unstained, undyed material of the same kind to achieve visual opacity. The surfaces are illuminated with a daylight simulator at a standardized illumination level. The visual differences between the original unstained and stained pieces are compared with the differences represented by the grayscale. The grade of the specimen is that number of the grayscale which most closely corresponds to the contrast between the original and the tested pieces. Shown here is an evaluation of an accelerated laundry test on a dyed knitted fabric attached to a multi-fiber strip. To the left is an unwashed multi-fiber strip for rating of staining. The scale is placed on the two multi-fiber strips with the masking window overlaid. The scale is moved back and forth to allow the rater to evaluate the specimen. After the first fiber strip is rated, the mask and the scale are moved down to the next fiber strip. In this case, a rating is given to each of the fibers in the multi-fiber strip and reported in the order they occupy in the multi-fiber strip. Here, the rating is done horizontally for ease of demonstration. The actual rating would be done vertically. AATCC Evaluation Procedure TM8, 9-step chromatic transference scale, is another procedure for measuring staining on undyed textiles during color fastness testing. This scale is the only evaluation procedure that uses Munsell color chips. This scale is comprised of 54 color chips. They are in gray and 5 Munsell hue families. These hues are red, yellow, green, blue, and purple. 5 rows and 6 columns are arranged, with the lightest chips on top and the darkest ones at the bottom. The same graduation in depth occurs for each vertical line of tiles. The colors are aligned from left to right as gray, red, yellow, green, blue, and purple. The neutral gray chips that relate to the grayscale for staining are aligned with the colored chips. The lightest colored or neutral chips have a grade of 5, and the darkest chips have a grade of 1. These are arranged from top to bottom as 5.0, 4.5, 4.0, and so on to 1.0. The chips on the scale appear in white cardboard in 10 rows. The rows are placed and aligned so that every color shows a similar gradation in depth in a vertical line, ranging from the lightest colors on top to the darkest colors on the bottom. There is sufficient separation between them to allow for circular holes of about 3/8 of an inch cut in the card between rows of chips in the 5 rows. For rating purposes, the rows are designated numerically, with number 5 being assigned to the top row, which depicts no color, number 4.5 to the second row, or lightest colors, and so on down to number 1 for the bottom row or darkest colors. A white cardboard mask is provided so that when it's held vertically over the scale, it discloses one of the circular openings in the color scale and the 2 adjacent colored chips. In practice, less experienced evaluators can use the AATCC chromatic transference scale to acquire similar ratings with those raters using the grayscale for staining. During the rating of the specimen, the surfaces are illuminated with a standardized daylight simulator. The incidence of light upon the surfaces is at an angle of 90 degrees and the direction of viewing of 45 degrees to the plane of the surfaces. A wet crocking specimen is used here to demonstrate rating with this procedure. An untested white crocking square is placed behind the wet crock specimen to prevent grin-through from the back. Then the specimen is placed under the colored tiles so that the stain is shown in a viewing hole. Next, the mask window is placed over the exposed stain and the tiles above and below the hole. The evaluator then views the level of stain as related to the color of the stain and the tiles. Here, the red tile for rating between the 1.5 and 2.0 values is observed. Often a comparison of the level of staining on the gray column of tiles is beneficial, as the color of the stain does not always have the same cast as the tiles. Here, the wet crock stain is compared to the grayscale to confirm the rating. The actual rating would be done vertically. Color measurement and the rating of color properties are properly described in the other AATCC test procedures. Often, supplier and customer agreements make it necessary to provide a reference document to support clearly the proper measurement as described in the procedures. AATCC Evaluation Procedure 6, Instrument Color Measurement, provides the means to perform instrumental color property measurement. In fact, many current test methods require instrumental readings. The test procedure contains three major subsections covering reflectance measurement, transmittance measurement, and related calculations. Also, there is an appendix which details specific techniques and specimen handling procedures. A color measuring instrument is any device used to measure the relative amounts of energy reflected from or transmitted through a specimen in the visible region of the energy spectrum. Colorimeters and spectrophotometers are examples of color measuring devices. The visible energy region is comprised of wavelengths from 360 to 780. Any opaque or nearly opaque material is measured by reflectance methods to obtain a numerical representation of the color of the specimen. Proper equipment setup, standardization of the color measuring instrument, and the proper presentation of the test specimens to the instrument are required to achieve consistent, reliable, and meaningful reflectance measurements results. In addition, calculation of the colorimetric values required for evaluating the results must be performed in the prescribed manner. Spectrophotometers measure the light transmitted or reflected for each wavelength in the visible spectrum by the fabric surface. This measured light is expressed as a percentage at each wavelength. Each spectral representation produced is specific to the colorant or mixture of colorants used in the object. As a result, a spectral curve is much like DNA or a fingerprint in that it identifies that particular color on that substrate. Colorimeters measure the tri-stimulus values, X, Y, and Z, directly through red, green, and blue sensors. Spectrophotometers have between 3 and 16 sensors. The physical color of the specimen is converted into numerical values by the colorimeter. These values are mapped based on three-dimensional Euclidean geometry. Color-related coordinates are represented by XYZ and LAB. Colorimeters are not as accurate as spectrophotometers or as expensive. A key to color measurement is proper calibration to standardize the instrument. Specific guidelines and procedures are given by both the instrument manufacturers and the test procedures and test methods. Color standards are very critical to the measurements, and care must be taken to properly care for the standards. Other very important considerations are the size of the specimen presented to the tester, the surface texture, and specimen presentation. The specimen must be large enough to fully cover the viewing port and to allow for folding or multi-layering. Napping, suading, shearing, and other finishing processes to create surface texture must be properly oriented for both the standard and the specimen. Specimens must be flat, smooth, clean, and other factors related to the presentation of the specimen to the tester. Of particular importance is the number of layers of the specimen used. Of importance is how the specimen differs in color from the standard. This difference is referred to as the relative strength. The values collected are used to calculate the relative difference between the two samples. The result of this comparison yields a numerical value which is termed percent strength. The final report of data gained through this procedure should include, as a minimum, the following information: the type of instrument, the color strength value calculation, the specimen presentation, temperature, and percent relative humidity, and the number of readings in the measurement. Instrumental assessment of color change can be attained by using AATCC Evaluation Procedure 7, Instrumental Assessment of the Change of Color of a Test Specimen. This evaluation can be used instead of Procedure 1, Grayscale for color change. Procedure 7 is effective as a rating tool unless the specimen tested possesses optical brightening or fluorescent whitening agents. A spectrophotometer is used. Calculations of color difference are mathematically expressed as a grayscale value. The color fastness of a product can change from consumer care or laundering, exposure to sunlight, heat, household chemicals, or other reasons. Test procedures to assess color fastness performance to laundering can be very stringent or mild. These evaluations have been developed to purposely identify problem fabrics. The normal expected life of a product and expected care will determine the severity of the test that will be used. Due to the large number of specimens that need to be tested by either a brand or a retailer, test procedures that are accelerated are preferred. Accelerated test methods save time and money. However, the results have to be similar to normal care. Some accelerated test methods acquire results that are equivalent to multiple consumer care cycles. Some tests are designed to replicate 3 consumer cycles and others to simulate 5 cycles. The number of cycles needed to be replicated is normally agreed upon by the parties involved in the buying and selling of the goods.